hello to everyone. So I'm going to jump straight into it. This is something I've prepared as part of the Holochain Playground effort to help visualize what's happening behind the scenes, right? For both Holochain and then how we are using Holochain to build our game, right? So is my screen looking good? Can you see more or less what's happening on it? Okay, cool. So this is something, we'll put a link on the Discord just after this. This is like we already showed you some of these an interactive simulation of Holochain. So these are not real nodes, these are simulated ones. But these nodes have installed the DNA for the game that we are going to be coding and finishing today, right? So here you can see that if I click a node, I can call some of these some functions from it, right? And then here on the bottom right, we have the entry graph. So all the entries that have been created and published and how they are related to each other. So what I'm going to do now is I'm going to disable the agent entries. For now, we don't care too much about those. What I'm going to do very briefly is run through the functions that we are going to call to actually create a game and see what entries get created and how they are related to each other. The idea is for you to have a high-level overview of the structure and the data structures that we are going to be using and how they relate to each other. So then the code makes much more sense, right? And in the future, you will be able to go into this link and play around with it and start to understand more and more, right? So let's run through, let's create a game, and let's actually start a session. So these two first functions, we already, those are the ones that we created in the first session. Sorry, not the first session, the last session. So create game code anchor and join game with code, right? So let's have Shana here create a game code anchor with the unique code of he. Okay, execute. That's going to be creating the game code and so on. And I'm going to talk a bit just first about this. Okay, let's see. It should be, oh, okay, we had bad luck. Let me explain it via this. Okay, so what I did is I executed create get game code anchor, and now I'm joining that same game with the nickname ASDF, right? So let's look at what has been created here. Okay, so we have anchor 0. Anchor 0 is the anchor from which all the games will be linked from, right? So anchor 0 is linked to the entry game code 0, and game code is just he. And then that has a link to all the players that have been registered in that game. So let's have Willa Vela, weird name, but I like it actually. Let's have Willa Vela join that same game with Willa Vela. Okay, execute, right? So Shana created the game and she joined the game as well. And now Willa Vela is just joining the game. So as you can see, we have the same anchor. And the only new thing is that there is a new player profile, right? And game code as an entry links to all the player profiles that have been created, right? And this is how we are going to get all the players for this game code, right? So let's try to actually now go and execute this. So this should be he. And this is one of the new functions that we are going to make. Get players for game code. So from a game code, get all the players that will be playing. So let's see, let's execute that. And we can see the results here. Get players for game code. And we have 1 player, 2 players with nickname SDF and nickname Willa Vela, right? Okay, so this is the basic structure of how the entries and the links look like after having created a game code anchor and joining that with different players. So now let's switch back to Shana and actually start a game session. And this is something that we will be coding along during today's session. So let's look at how it looks. Start game session with code, what it basically does is get all the players that the game code was linked to, and then create a new entry game session with those players actually playing. So let's see. Okay, so what this did, if you can see, is from that same game code entry, yeah, that's okay. From that same game code entry, we have linked to a new game session 0 entry. And this is an entry that we are going to be defining and then creating today. So from this, you can do things like, okay, from the game code, you can get links and get the game session in itself. And then Nastasia is going to talk about what's inside the game session and how it is related to all the players and so on.
Okay, so first I wanted to recap. I mean, I already have this picture, which kind of repeats what Guillem just said, but in another form. So last session, we have written the code to implement those entries on Holochain. So we are able to have a hard-coded anchor to attach all game codes to. And in my scheme, there are two examples of game codes, one without any players and another one with Alice and Bob. And for every game code, it would be attached to an anchor. And then from this game code, we would have links for every player profile who has registered for this game code. Now, that's the code that we're building on top on. So that's not something we will be doing today. Okay, so that's the entry diagram for the code that we would have by the end of our session today. So we would be adding a new type of Holochain entry called GameSession, which would store all of the data for a specific game to be played. And then this GameSession entry would be connected to the game code by link with the tag GameSession. And also it would be connected to the player who has created this game session. In our example, this is Alice, by another link with the tag MyGame. This way, an owner of the session would be able to list all of the sessions they have created. So that's as far as the entry diagram goes. And now let's go to the code. So I want to try something different today. Instead of trying to kind of type code in real time, I will just be switching between multiple commits and then just go through the code that's already written. And let us know how it goes, if it's making it easier to read the code or not. So yeah, give us some feedback. So that's the lib.rs file where we have everything that we have written previously. So entry definitions and just 3 functions that we have exposed. I have created a new file, which is called GameSession, which contains a lot, and we would go line by line here. So this commit contains entry definitions for the game session and all of its dependencies. Since our game session would contain quite a few things, there are actually multiple data types to be defined. So these lines are just imports that are necessary to make the code that's written here to compile. And then let me first overview the game session, and then I would go back to everything that it contains. So this is a definition of our Holochain entry for the game session. This macro should already be familiar to you because we used it in player profile, and it defines that our session would be public, meaning it would be stored on DHT, and then the entry during the serialization would be called game session with the camel case. Sorry, with an underscore. So the game session structure itself would contain the following things. First, we would be storing a pub key of an agent who has created this game to identify the owner. Second, we would be storing the state of our game session, and there would be actually multiple ones, but we would define them later. For now, just think about the session having some kind of state, which is defined by another type. Then our session would have a bunch of game parameters, which we decided to separate into another structure because right now our code is written in such a way that we do not provide ability to configure the game parameters through the user interface. But once we do, having a separate structure for game parameters would make it easier to send them separately over the API and to perform all kinds of other actions. So it just makes it easier to separate concerns. Next, we would have a list of players where every player is identified by their pub key, because for the game session, we don't need to actually display their usernames, so we don't care about them. And then also our game session would have the scores, which would help us to store the actual results, like who has consumed how many resources. And yeah, that's basically it. And then the last part is an address of an anchor. So going back to my scheme here, that would mean that address of this entry game code to which game session is attached would be stored here as an entry hash. That would mean that there would be an ability to discover both things regardless of where you are. So if you know the game code, you would be able to discover the game session that corresponds to this game code. If you only have the game session, you would be able to get the game code that corresponds to it because you would have its address. So that's just a nice thing to do. And also, if by any chance we have a game session that has all these parameters, which are absolutely the same, but belongs to a different game code, that would protect us from the data collisions, because this entry here would make hashes different. So no problems would be created. Now let's review things that are making our game session. So first would be the game session state. And that's an enum, meaning that it's a limited range of values. And at any moment in time, our session state would have to be one of these three values. So according to our game flow, we are only creating game session once all of the players that want to play the game have registered with the game code. And we kind of assume that the game owner, the person who has created this game code, can decide if everybody joined the game or not. Like they have sent code to 3 people, so they would be waiting for 3 people, and it's completely up to them to start the game. So since we're only creating game when it's already ready to be played, we only need the in progress state. So we don't need to handle anything that happens before that. And we do not have to create the session state, the game session object with a state that wouldn't be in progress. That would be something waiting. So that's simplifying things for us a bit. And then we have 2 other values, which would be defining a game session that has been played already. So we would have 2 different values. First one would be for a game session that has been lost. Since we're implementing a game called Strategy of Commons, losing a game collectively would mean that we have depleted all of the resources that we've had, so the strategy happens. But if we do not deplete all of the resources and manage to keep them at above 0 levels during the entire game, then the game would be finished, which would mean that there is some game score to be checked and there are some winners, and collectively we have all won because, well, we kept our resources. And having the last round entry hash in both lost and finished states would make it easier for us to traverse data for existing game sessions. Because imagine if there would be 20 rounds.
Oops. I guess we will wait until Nastasia comes back.
I'm so sorry.
That's fine. We got some space for a commercial break from our sponsors.
Yeah, I take your sponsors are producing new CPUs, which do not freeze so frequently. Okay, so what was the last thing that still got through?
You were talking about why you have the last round entry hash there.
Okay, thank you. All right, so yeah, having this last round hash would make it easier to traverse to the last round instead of having to go through the entire chain of rounds from the beginning. So that's for the state. So once again, this is this parameter. Now, The next one is the game parameters. We have only 3 values here for now, which are necessary to calculate the game. First one is the regeneration factor. That is a floating point value which would be applied to our resources in pool on every round, and that defines how fast the resources would regrow on every round. So this value could be below 1 or above 1. So it could be a negative growth, theoretically. We wouldn't have to do that, but it's a possibility. Next, we have the resource amount, which is just the amount of resources that we have at the beginning of the game before anyone made any moves. And for the resource amount, we have actually defined an alias. That's just an integer with a signed value, meaning that it could be both positive and negative. And having this alias is very useful because, first of all, it would allow us to separate all of the integer values that are storing some random data from the integer values that are storing the resource data. And second, if at any point in time we want to change this I32 value onto something else, we would only have to do it here once, and then the rest of the code would already be using this resource amount alias. So that's just a nice touch. And then the last parameter in the game parameters is number of rounds in our game, which is kind of self-explanatory. And then what's next? We also have the player stats. Player stats is also another alias, which we have defined here. And under the hood, it would just be a map which maps a single value of agent public key onto a single value of the resource amount, meaning that for a list of players, we would have every player's key and amount of resources that they have consumed during the game. And a very important note here is that instead of using the hash map, which is also a map implementation available in Rust, we are using the B-tree map. And the importance here is that hash map, unlike B-tree map, does not guarantee the order in which its items appear. And in Holochain, everything is hashed. Every entry contents are hashed to be stored on DHT. So if we are working with a data structure inside of a Holochain entry, which does not guarantee the order of items, then we could theoretically have different hashes for the same contents, because different fields in a map would be appearing in a different order. Having B-tree map resolves this problem and protects us from any random changes in our hashes with the same contents. So that's for the player stats. And the anchor I have already explained. That's the definition of the game session entries. And this is written in a separate module. And in the lib.rs, you can see that I have added this module here, meaning that if I remove this line here, it would tell the Rust compiler to ignore this file. So it wouldn't even attempt to compile the code. So I could be making all kinds of errors there. So to make sure that it all works, let's add this here and try to build an application. So that's me in the root of the repository that we have already created, executing the npm run build h up, and that's the script which is defined in the repository. So that's taking a bit some time, and we can see that our code is now compiling. Before I move on to the next commit, are there any questions about things that I have shown right now?
Yeah, I have a quick question. I'm just wondering if under the session state, so lost and finished takes a parameter last round. Has that just not been defined yet? Like what's the round, the struct for a round?
Oh, yes. Yes, round we would be defining next on the next DevCamp session to avoid overloading you with details.
Yeah.
So
okay.
Yeah.
Thanks.
That would all make sense.
Rising Walter has a question in Discord, which I think you addressed, but you might want to repeat. I believe that hash are not unique. There is a big chance they are, but we could, in theory, have two different entries having the same hash, isn't it? How we dealing with such collision cases? Yeah,
that's exactly the reason why we have this anchor here. And you could also add the timestamp into your entry to reduce the this problem even more. But yeah, I think this already has been discussed in some of the sessions on Discord. I think Tim provided some links about it too.
Yeah. I think he might have meant different actors putting in the same content and therefore getting the same hash. But yeah, and so
that's the thing.
Yeah. But I think the way you handled it in this code, do you want? Because I saw you covered it about 5 minutes ago.
Yeah, so the thing is, it's impossible under the current implementation to create a game session that would be identical but would be created by two different agents. Because as I will show later, this field of agent pub key is not even taken from the user interface. So you cannot provide this parameter as an input to your backend. Backend would calculate it itself. I would be switching to the next comment then. So we have written this code here in the game session, but we only made our code available for the Rust compiler. So Holochain as a framework still doesn't know anything about new entry being available. So in order to make this happen, I would go to the lib.rs here, and I would be adding this, this line of code, and then the comments on top are just a detail. So that would say to the Holochain that, hey, we have a new entry called GameSession, and that's the function that provides its definition. Similarly to the player profile, you wouldn't find an entry definition function anywhere in the file because it's a function which is generated by this macro during the compile time. So that's as easy as adding one line of code to make our Holochain entry available. Now that we've did this, we would want to actually implement a function to create a new Holochain entry called GameSession. So let's go here. Sorry, 1 second.
I think you did the checkout with the same hash.
Yeah, thank you. Still, okay. Am I going crazy? No?
It's like, okay, that's already done. No, go back to the list. Okay, we already did.
Yeah, that's for messing. That's what I get for messing with the Git history. We had two different comments there. Okay, all right. We have this function which has the following signature, and since we need the list of players for our game and some game parameters, that's what we're getting as an input, and also the entry hash of the game code anchor that should already exist at this point. So with this set of data, we are promising to return an entry hash of the resulting game session currently. So what do we do here? First thing we do is we get the info of the agent who is currently executing this function. And that's where we would get their public key from. So that wouldn't come from the UI parameter. And so this is a function provided by the HDK, which you can call in any function. And it would just give us a set of data about the agent. With that being done, it doesn't take us much to create an actual Rust instance of the structure called GameSession. We already have the agent pub key of the person who is running the code, so we assume that they would be the owner of this game session. Next, we know that the game session is just created, so we are setting it into the in-progress state. And then we also have the game parameters here, which we can just pass as they are, and the list of players, which we can also pass as it is. So that's all assuming that somebody provides this data into the function. And then we have the new player stats. And since there is nothing yet inside of the game session, that would be just an empty B-tree map with nothing inside it, like absolutely empty thing. And then we also have a game code anchor, which we're providing here. And notice the .clone method, which means that we have received a known value of the anchor here, and now we have to clone it because the game session Rust struct would need to have a known value of anchor itself. Okay, so now that we have created a Rust structure, we need to actually commit this piece of information onto the DHT. So we do it by calling the create entry function. It would create a new element with entry which contains this data, and then it would make it available to other nodes on the DHT. Now, we would need a hash of the resulting game entry to return it from the function and also to use it for link creation. So we calculate this hash here. Now that we have this hash, we can create the links that, so these this is the code that's creating these links. So link number 1 and link number 2. Sorry, yeah, they're in a different order. So that is creating link from the public key of an agent who created the game to make it accessible for them via the tag, which we define as a string value on top of the file, which is just called my games. And then similarly, we would define another tag value, game session, which we are using here to create another link to make this game session discoverable for everybody on the DHT, because they would be able to follow from the game code's anchor into the game code for the specific game session, and then into the game session entry. So that's here. And once we've created those links, there is nothing else to do for us right now. So we can just return the entry hash. Next time, when we would be implementing the game round, which has to be started once the game starts, we would actually add code here. But until then, in order to make the code compile and to be able to test it, we would be just returning the hash of the entry. Yeah, any questions about this part?
We have one question, just a quick point. We have 10 minutes until the midway point. To take into account. Shane has a question. Why do we need to call players.clone and anchor.clone, not for game params?
So first I can answer about the anchor. So if I select this value here, you can see that we will continue using anchor after we create the game session here. Yeah, basically only here. So we would still need to have this value. So in order to do that, we need to clone it, because we need to own this value here, and the game session also needs to own this value. So we cannot work with the same memory allocation for anchor. We need to make 2 memory allocations. But for the players, actually, looking at the code right now, I realized that we do not need to call clone, because we don't use the player's value anywhere inside of this code after we have created the game session. So I will fix it in the repository later after this call. I hope I answered the question. Okay, so now that we have created our game session entry out of thin air, without any connections to anything that we have written so far, we need to integrate it with the code that we've written before. So in order to do that, let me go to the next commit. And we would be creating a new function here, which is called start game session with code. That function would provide us with an integration between the game code functionality and the new session functionality. The input parameter is the game code, and that's something that user would be calling from the user interface, like, hey, I want to create a game, and the user interface would already have this game code, and we would receive it. So inside of this function, first thing we need to do, we need to actually get the anchor for the game code that we received. Now that we have an anchor, next we are retrieving list of players who are registered for this anchor using the functions that we've implemented last time. Now that we have a vector of player profile, it would have actually made more sense if we did it like this. So we have vector of player profiles, but our new session actually accepts vector of pub keys. And every player profile contains a pub key inside of it. Let me go to the definition to refresh. So that's our player profile. And we see that out of 2 fields, we only need this one. So in order to unpack values from this vector of player profiles, we are doing this kind of Rust magic, which if you're not into parsing Rust code, just think about it as a data extraction, where for every value of player profile, we are only extracting its pub key part, and we don't care about the rest. So nickname, we are not collecting. So now that we have transformed this data, we have player keys which are ready to be used. And the last thing we need to create is game parameters. So for now, we're creating game parameters as a hard-coded value here. But if you are interested in, you could refactor the code in such a way that this would be accepted from the user interface. So user would be able to define the actual parameters of the game they want to play. Here you can see that our resources would be growing 10% every round, and we would be starting with 100 of resources total for the entire game. And our game would only have 3 rounds. So by the end of the third one, if resources are still positive, it means that our game is finished. And now with all of these values that we have gathered from the other modules, we are able to call a new session, and we are just returning whatever the new session returns. So return value of our function here is an entry hash inside of the external result. And that's the same return value as we have inside of the new session. So we are just passing all of the data and then taking this function and its return value as a result. That's it for this part.
Before starting, I would like to add 2 comments in programming in Holochain for you guys. Number 1, how to look at the links, split it up the topic of the anchor. Anchor is a pattern, and link. Generally look at the link as giving a more meaning to the entry. If you would like to do more query, because the entries, the content is going to be in the DHT and we cannot easily find where is it. So, and that's why we are adding a more link between the entry to giving it more meaning, to make it much more easier to do a query. So it is one point. Another one, if you are already a programmer and you are using ORM, object relational mapping, in your programming language, so you already know that in a database we are saving data, and when in an application we are mapping it to object. So in the application, game and other applications in the ecosystem, if you see a lot of enumeration, enums, and struct, all of them are not being saved in DHT. So only in the entry definition, the entry you see there, they are going to be in the DHT. So the enumerations, all struct you see in the in modules or any classes, but we don't have a classes. In any file you see, all of them, all the program are not saved in a DHT. They are just kind of a struct that giving a more meaning and logic to your application. If you would like to see what it's going to be saved in a DHT, you need to look at the entry definition. These 2, I was thinking it can be helpful to share with you.
Thank you for that. Yeah, I think I would just get back to the code that I've been showing. We have one more function to cover, and then we're almost ready to go into the Q&A. So what we have stopped on, we've created a new game session, and we're able to connect the game session entry that we can create with the game code and player profiles. Now I want to show you an example of how to make a source chain query. It's not strictly necessary because our game session code, going back to the diagram, so this link here already makes game session available to its owner if they search for the links starting from their public key with this tag. But there is a way to do this query and retrieve all of the game sessions that you own without actually going to the DHT. And that's why I wanted to show it. So since a game owner would be creating game session themselves, this game session would always first go into the source chain. So if you want to see everything that some agent has created, we can just query their source chain without network queries. So this is a function that would be retrieving game session that an agent owns. And the return result of this function is defined here. An interesting thing that you may notice is that it's different. And we are not only returning an entry hash, we are returning a tuple of entry hash and game session structure for any element of our vector. And that's very useful because game session here would actually pack all of the contents. So things that we want to show user on the user interface. And then, things that an application needs. And then the entry hash would correspond to the hash of the game session entry, which has those contents. So if user interface wants to call a function on a specific game session, for example, or just know what kind of data is stored under which ID on Holochain, we would be returning an entry hash. So yeah, basically think of this thing as an ID for your piece of information. So the first thing here that we're doing, we are creating a filter for our source chain to be applied. So these lines of code here, they are not doing anything. They are not executing any queries. They are just setting the parameters for the query execution. HTTP provides this struct called ChainQueryFilter, which allows to implement those filters. And I wouldn't be going into details. I would just go through things that we do here. Since we are after actual game entries, so we want to have data contents stored on DHT, we are adding this parameter. Otherwise, we could be querying on the headers, which do not contain any data, and that's not what we need. So that's the first thing we want to filter. The second thing we want to filter is we only want to get entries of the data type session. So we are wrapping this requirement into the entry type function. And then through some rather peculiar Rust thingies, we are getting our game session definition. So we are saying that get us entries that would convert into this Rust structure and then would have the visibility public. So these would be the entries that are not only stored on source chain, but also propagated to the DHT. With that being set up, now we are actually executing this filter. So that's where we query a source chain of agent who is executing this code. And as a result of running this filter, we would get a list of elements. So now, in a way similar to the player profile, which I shown last time, we would go through the list of elements and try to convert them into the actual game sessions and the entry hashes that we need. So first, we are creating a temporary vector to store our results. And that's not strictly necessary. In Rust, there are better ways to do that, but this one is more readable. So we have our intermediary data structure for results. Now we are iterating through a list of elements, and every element here is called L. So first thing we want to do, we want to get an entry underlying one which is stored with this element, which we're doing with this function. I've covered this in the previous session, so I wouldn't be going too much detail here. So just we are getting an option with an entry. So there is no guarantee there would be an actual entry. So to unpack this option, we are doing this one, absolutely similar to the player profile. And the thing that's different is how we get the entry hash. Since we already have an element which contains both header and entry, we already have data about entry hash, so we do not have to calculate it by calling the hash entry function. Instead, we are just getting the header data from the element. And then inside of each header, there would be a hash of an entry to which it corresponds. Rather there would be an option with a hash, which could be none. And that's what we're handling here. So we are getting an option with a hash, and then this construction here, like that, is unpacking the option we received with a hash. And if for some reason there is no hash inside of it, this error would be returned to the user interface or whoever is calling our function. So now that we have the game session entry itself and its hash, we are forming the tuple out of those two here, right in place. And then we are providing this tuple as a parameter to insert into our vector code list of tuples. And once we're finished with our for cycle, we just return the list of tuples that we have as a result. So that's for querying the source chain. And so up to this moment, and you can see here, I had to add the allow that code because I have written three new functions in GameSession. So we have this one, and this one, and this one. All of them are public, and none of them are used inside of this module. So in order to make this code compile, I have to have this thing here, or I could apply it on the entire package module, level, but that's not necessary. First, let me make sure that the code builds. It would take a few short moments. And now, what do we have? We have functions, we have entry definitions, but these functions are not callable from the outside of our backend. They are not exposed as XOM API. So in order to do that, I would expose those functions here. So lib.rs has changed a bit. And you can see that there are now 2 more functions that I have added. These wrapper functions, they have the same signatures as the underlying GameSession functions. So this is the same as the start GameSession with code. And this is the same as get my own sessions via source query. The important note that I want you to notice, this function get my own sessions, it returns the result of a function which doesn't accept any parameters. So you see that here we only have empty braces. But here you see the underscore and the UnitType. This thing in Rust is called UnitType. That's a requirement of an HDK external macro, which requires a function to physically have some parameters defined. And that's basically a Rust way of defining a completely useless parameter, which is only here to comply with the syntax requirements. So in any other Rust function that doesn't have the HDK macro applied, you can just skip it and write an empty braces instead, like I did here. But this is necessary to make the code compile. So now I have exposed these functions through the XOM API, and now a user interface and integration tests can actually call them. And so to verify it, let me go to the next commit where I have written the integration tests and try to run them and see how it goes. So first, after the tests are written, I would need to rebuild the application because I don't think I did. Yeah, I didn't build it when I exposed functions through the API, so new changes are not applied. So now we need to wait while it's building, and now, okay. And now we are executing the integration tests. For now, I'm trying to not focus your attention on how the tests are written. So the only important thing for you is that they are working. And if you change something in the backend code, like return values would be different and compiler allows it to work, you could see if your changes affect the integration tests. So there is a bunch of output in the tests that's describing the version of Holochain that's being used and also producing a lot of output from how things are being executed. You see that we have 8 tests, all of them have passed. And let me quickly scroll through the execution. So you can see the output that I have written in the tests where Alice has created the game code. And that's actually how it looks in the deserialized form without being converted into a string value. So Alice has created the game code. She shared the game code with Bob, who also registered himself for the game. And then Alice has joined the game with her profile right here. And then Bob joined the game as well. And then Alice is able to see that there are certain players in the game. You see there are 2 of them. And these are contents of the player profile struct. So the public key and the nickname. And the next thing that's happening is Alice is creating new game session by calling the start game session with code. And that's the result And then Alice and Bob are both calling the get my own sessions. And for Alice, the result of this function would contain one item, which is the game she just created. But for Bob, this would contain 0 items because he didn't create any game himself. He only has joined a game that Alice has created already. So that's for the testing. You can check out how it works. You can change something in the query functions and see how tests would be broken. And we can go to Q&A now.